Energy efficient Ethernet is important because it's a well-known fact that energy use is on the rise. A researcher from Berkeley lab contributed to a congressional report in 2007 that showed the increase in energy use in data centers between 2000 and 2005 and concluded that if there's no change in the way that we use energy in the data center, then it will double again in the next 5 years. So when you combine that with the increasing cost of energy, it's clear that something needs to be done to reduce energy use in the data center, and energy efficient Ethernet is one of many things that can contribute to the reduction of energy use. Energy efficient Ethernet came about as essentially an idea from a colleague of mine at Berkeley lab, Bruce Nordman, and a colleague of his, Dr. Ken Christensen from the University of South Florida. They had the idea that since Ethernet is a bursty protocol, not fully utilized, that there would be an opportunity to save energy by switching to a lower speed. So they measured some devices with a power meter and looked at the difference in power use at different speeds and determined that that was indeed the case. So that was sort of the brainchild of energy efficient Ethernet. The Ethernet Alliance came into play by hosting a white paper that Ken and Bruce had written, which drew attention to the project. We were considering starting a project in the IEEE, and that white paper being posted on the Ethernet Alliance website, in addition to several members of the Ethernet Alliance who were also participants in the IEEE, started building that consensus we needed to get to have a successful call for interest. So it was the combination of their idea and the incubation period or incubation feature or function of the Ethernet Alliance that got us off the ground and got us started on a successful project. Energy efficient Ethernet, as I mentioned earlier, started off, we were looking at changing speeds to save energy. And one of the issues with changing speeds is that there's a period of delay, what we call the transition time, which wasn't so critical when you go from a high speed to a low speed. But when you go from low speed to high speed, that link needs to go up as quickly as possible. And there were concerns with that transition time when we studied that particular technique. So later on in the project, we found as we tried to optimize that transition time, some other people brought in a different idea that's called low power idle. Low power idle is essentially a protocol that communicates between link partners and tells one end of a link to go to sleep when there's nothing to send and wake up again when there is data to send. And then there's some refreshes sent in between to keep the receiver from drifting to the point that you don't lose the link. So it's a very efficient protocol and allows us to save energy at the physical layer device, the port itself. But what's key to low power idle is not only the energy savings at the PHY, what we call the PHY, the physical layer device, but also the system's energy savings that can be had because of the protocol. When you tell a device to go to sleep, it can also tell other parts of the system to shut off. So there's even more energy savings to be had beyond just the physical layer device. The phase of the project in which we're at now is task force review, which means we've produced a draft. We've reviewed that draft, and after reviewing the draft and taking the comments, we've directed our editors to produce the next version, which is draft version 1.1. So we'll continue this revision process for a few months. If we stay on track, then I expect we'll enter the next phase sometime towards the end of the first quarter in 2009, which will be to say that we have a technically complete document and allow the 802.3 working group to review it. Assuming that that stays on track, then we're looking at March to no later than July 2010 to have a completed standard. Once the standard's done, then how soon can I expect to see products, and what does that mean in terms for Ethernet and for energy efficiency? You know, to speculate, I would say that I wouldn't be surprised to see energy efficient Ethernet products mid-2010, maybe third quarter 2010. And then from there rolling out as new Ethernet products would normally roll out. The interesting thing, and the thing that I look forward to, is seeing the actual product, or the reduced energy in, say, the data center or in the enterprise, where we actually get to see the fruit of the project. That we've developed a standard, and industry takes that standard and develops the products, and now we actually see the energy reduction that we've been hoping to achieve.